Welcome to In 5 Minutes. The agenda of this clip is to understand a phenomena called as crosstalk. Now, we know that when an interconnect is nothing but a wire, we already discussed that. When an interconnect line is placed in close proximity to any other interconnect line, both these conductors are coupled by a unwanted capacitance or by a parasitic capacitance. This is nothing but the coupling capacitance. Technically, each interconnect would have its own capacitance, that's called the self-capacitance, and if they are placed in close proximity to one another, they would also be coupled by a coupling capacitance, also known as parasitic capacitance or an unwanted capacitance. Now what's going to happen due to this unwanted capacitance is, if you pulsate the voltage or if you have a voltage running on one of the interconnect lines, it will lead to a switch over or trigger or an unwanted signal on the line to which it is coupled to. In simple words, if we have to understand what I just said, it's nothing but all the wires or the interconnects have capacitance to their adjacent neighbors as well as to ground. Let's understand this. So this is suppose interconnect A, this is interconnect B, this is the self-capacitance towards ground, self-capacitance towards ground, and this is the coupling between the two of them. So wires have capacitance to their adjacent neighbors as well as to ground. When wire A switches or internet A switches, it tends to switch in some direction interconnect B also when it is not supposed to switch. And this is because of the capacitive coupling between the two, and this phenomena is nothing but crosstalk. So we just understood what is called crosstalk. Now let's go ahead and put this and find the value of that coupling capacitance. Here there is my line 1, here is my line 2. Both of them are my interconnects or wires. They both have this coupling capacitance, correct? Now we know that line 1 and line 2 are coupled to each other by this coupling capacitance, also known as parasitic capacitance. What do we know from the formula of capacitance is? Capacitance is nothing but epsilon into A upon D, which says that if the distance between the two interconnects keep on reducing, which is to be the case when you talk about high density VLSI chips, then the capacitance between the two keeps on increasing, correct? So if this distance, or in this case this distance is nothing but the spacing, if the spacing between the two interconnects is reduced, then the coupling capacitance or the capacitance increases. Now let's say that this is my line 1 with voltage V1 and this is my line 2 with voltage V2, and the coupling capacitance is given by Cc, then the voltage difference on the two lines V12 will be given by V1 minus V2, and we know that I is equal to Q by T, which is nothing but CV by T. Q is equal to CV. That means I is nothing but Cc. Now this C is nothing but the coupling capacitance. V is the difference in the voltage, which is V1 minus V2 upon dt, because technically I is nothing but dq by dt, rate of change of charge with regards to time, correct? And Q is nothing but CV. So this is nothing but C dV by dt, correct? So this equation clearly tells us that strong coupling exists, or the current will flow from 1 to 2 if Cc is large, or if the voltage difference V1 minus V2 changes very quickly with regards to time, then this I12 will be a higher value, which will lead to a stray signal or an unwanted signal into a line or into an interconnect where it was not desired ideally.